இந்த கவிதை ఇల్లు చూసేస్తా మళ్ళీ నా మీద సీరియస్ ఏం పని
We shall initiate today's proceedings with lighting of the lamp by our dignitaries. I request our keynote speaker, Mr. Imran Wadkar sir, Mrs. T. Anuradha ma'am, Head Department of Commerce, Mrs. Mahita ma'am, Dean Student Affairs, to do the honors of lighting the lamp.
शुभं कुरुत्वं कल्याणं आरोग्यं धनसम्पदा शुभं कुरुत्वं कल्याणं आरोग्यं धनसम्पदा शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते 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 दीपज्योतिपरब्रह्म दीपं सर्वतमोपहं दीपज्योतिपरब्रह्म दीपं सर्वतमोपहं दीपेन साध्यते सर्वं दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः आरोग्यं धनसम्पदः आरोग्यं धनसम्पदः
Thank you, Srija and Madhumita, for the divine singing. Let us all hope that we be the light that helps others to see. I now invite Mrs. Mahita Davala Ma'am, Dean Student Affairs, to speak a few words about the college. Today's chief guest, Dr. Vinod Kumar Murthy, National Head, IT and Analytics Education, Resource Person, Mr. Imran Watkar, data science enthusiast, trainer for data analytics, students from Government Degree College, Begumpet, Koti Mahila Women University, Reddy College, Badruka College, DTWRDC, Giriraj Government College, joined both online and offline, students of our college, St.Ann's College, and head of the department, Mrs. T. Anuradha, faculty, madam from Begumpet Women's College, and our faculty members, student organizers. A very good morning to one and all. I bring greetings to you all on behalf of our dear principal, Dr. Sister P. Amrita, and our Dean Academic and IQAC Coordinator, Dr. Smita Astana. As they were busy otherwise in another meeting, they couldn't make it. Coming to our college, born in 1983, in a two-room college with 106 students, St. Anne's has emerged as a leading institution with 35 program options and 4,000 plus students. Besides pursuit of academic excellence, the college imparts education with a mission of transforming its girls into empowered women who are socially conscious, intellectually competent, morally upright, and physically healthy. Re-accredited by NAC with an A+ grade in third cycle and the status of college with potential for excellence by UGC twice in 2010 and 2014 is a manifestation of our commitment towards quality education. College is certified with ISO 9001-2015 and ISO 14001 and 2015. Coming to our department, Commerce Department, now it has 7 BCom options. BCom General, Foreign Trade, Computers, IFA, Honors, Business Analytics, and BPM. Largest department in our college, having 1,620 students and 19 faculty members. Strategy to accomplish the mission of the college is rooted in creating a favorable academic environment to promote teaching, learning, and research, monitoring standards to make quality an integral part of the institution. In this context, department is organizing 2-day national level workshop on EDA and BI in collaboration with ISDC and IOA UK. Workshop of this kind will help the commerce students to learn fundamental concepts of EDA, skills required and hands-on experience, which will enable the students for the bright future. We acknowledge the presence of all the students who are present in both in offline and online. And I wish you all the best. Have a great learning experience. God bless you all. Thank you.
Thank you, ma'am. I now request Supriya ma'am, Program Coordinator, to enumerate us about the workshop.
Very warm greetings to all the participants and the audience here for this workshop. Good morning. Today I, Mrs. N. Supriya, Program Coordinator, Business Analytics, shall be walking you through the workshop. So, in today's business environment, we all need to understand, analyze and present data. Tools such as Excel and PowerPoint are fine, but when it comes to basic greater data challenge, we all need more serious tools. Okay, so one day in this workshop, one day we will explore, day one we will explore Python as a data analysis tool, and we are going to cover the basics of EDA using a data set and introducing you to the practical knowledge and the main pillar of EDA, including data exploration, data preparation, data visualization, and data relationship using a Python programming language. Day 2 will be focusing on Microsoft Power Business Intelligence, which is the most powerful self-service business intelligence platform. Power Business Intelligence is in demand, and many businesses use it for data analysis, data handling, and data presenting. This two-day workshop will provide you with the knowledge of tools and concepts using Power BI, a basic introduction to Power Business Intelligence and its functionality like data tags, data uploads, etc. At the end of the workshop, you will be able to understand the fundamental concepts of EDA using Python, develop the skills required to carry out a preliminary integration of any data set, gaining hands-on experience that can be taken to place of your work, learn how to apply Power Business Intelligence for best practices that are in tune with current and technical requirements. So, this is two-day workshop sessions, girls. Okay.
Thank you, ma'am, for sharing the objectives and expected outcomes to us on today's workshop. I now call on Mrs. T. Anuradha ma'am, Head Department of Commerce, to introduce our collaborators and our chief guest.
A very warm good morning to all of you. At the outset, let me apologize for the delay and the technical glitch. It was more with the rain that had hampered the electrical and power supply. That's what I hear. Thankfully, it was restored quickly, and my absolute apologies to our resource speaker who had been here from 8:30 in the morning. Though we know him, but this was not the way we could conduct a workshop. My absolute apologies to you, sir. And for all the students who had come from other colleges, thank you for making it in the morning, early morning. We actually proposed to start at 9:30, but then we thought we'll prepone it 15 minutes before, complete the inaugural, because we had a chief guest from the Institute of Analytics UK, the national lead, and the Analytics Educational Center at Bangalore, who wished to join, and we invited him to be online and speak a few words on the session, and he was invited as the guest speaker. Unfortunately, he won't be available, but on his behalf, I would definitely thank all of you for taking the opportunity, taking time, and coming to the campus to visit and to attend the workshop for 2 days. So let me continue with the purpose of why I'm here. We are collaborating with ISDC, the International Skill Development Corporation Limited. It is a UK Skill Development Corporation. We have tied up with them for an integrated program in BCom ACCA. And eventually we went on in 2017, we have tied up with them, we have collaborated with them. And in 2019, we have also extended it to Institute of Analytics, which is also a partner to ISDC. They are the members with ISDC. And Institute of Analytics is exclusively an institute which offers analytical education. So we have their headquarters in UK, and the national headquarters or the branch which operates from Bangalore. So Mr. Imran is from the Institute of Analytics Bangalore, and he is in the campus on this purpose of teaching analytics for our integrated programs in BBA and in BCom. So International Skill Development Corporation is a limited company registered in the Companies Act of England and Wales 2006 and has its operations across the globe in close to 180 plus countries. It imports a set of skill development activities through the structure and plan and aims to developing skill for tomorrow. The operation includes various skill development projects, professional and vocational education activities, professional and corporate training, consulting, research and development, and other learning solutions. ISDC have set the platform to share the responsibility of developing the future skills with the services globally. It is well positioned to meet the increased demand for skill development and professional education. So we are very happy to tie up with an international body, and we've been very successful with the ACCA program. And we also wanted to map our BCom analytics so that we'll be able to give an international certification to our girls. Now coming to Institute of Analytics, it's a global body of analytics, and it is a UK-based professional body for analytics and data science professionals across the world. They are a not-profit organization that is committed to advance the study, application, and standing of analytics and data science in the society, and they exist to promote greater awareness, understanding, and innovation in analytics. So there are a passionate set of individuals. You should be listening to Dr. Vinod Murthy. He's so passionate at this age that you can see him bubbling with the energy, and he talks what's analytics, and it's very unfortunate I can't get him today online, but we'll just get to understand his profile. I would read out his profile as well because we started late. We'll just compensate for the loss of time, and we will go ahead with the technical session as quickly. So Dr. Vinod Murthy sir is an industry turned academician who has a vast experience of 17 years in engineering industry and 20 years in academics. Dr. Vinod holds an engineering, if you can, his service. Okay. So Dr. Vinod holds an engineering degree, mechanical MBA, and MBA in finance and marketing, and a PhD in finance. During his engineering career, he had served organizations like Wisman, Forging Limited, LML Limited, Rotopumps, and others in India. He has been to Germany, Bahrain, and Sydney. He is presently associated with ISDC. He is the National Head IT and Analytics Education, and he is also won the Saraswati Seva Puraskar by the Lions International Club Kanpur, and the second prize in Best Doctoral Paper Competition in 2013. And Dr. Vinod is passionate about data science and is currently engaged in writing a book in multivariate data analysis. And Dr. Vinod loves to share his knowledge about SPSS, and he has got several other credentials. And if he would have been here, it would have been a great experience for you to. He will make analytics as if it is a cup of tea. I remember his sessions earlier. He would make it so simple, and anybody who has no technical knowledge would understand it to be so very simple. Okay, so without much ado, I will quit and allow for the technical sessions to resume. Simran, hold on. We'll not have any tea break, and the inaugural session will continue with the technical session of Mr. Imran. We'll start off with the profile, and then Sir will take over the session. Sir, because we're already 10:15.
It's my honor to introduce our resource person, Mr. Imran Watkar, sir. Sir is an expert trainer in the field of data analytics and artificial intelligence. He has completed bachelor's degree in electronics and telecommunication in 2011 from Mumbai Universities. He is currently working as faculty in International Skill Development Corporation, Bangalore. He has 8 years plus experience in the field of IoT devices and analytics training. Sir has worked on several projects in the field of IoT devices with clients like Dubai Police, Fujairah Oil and Gas Corporation. The key disciplines and areas on which he imparts training are artificial intelligence, Internet of Things, and programming based on C, C++, SQL, SAS, Python, R, Tableau, and Power BI. I now hand over the session to you, sir.
Hi, good morning. Thank you all for coming here and joining us in this wonderful session we'll be having for next 2 days. Unfortunately, Mr. Vinod was about to join you and he was about to address you so that you have a little bit of energy before we start with the session. Okay, but let's begin with the session points. Okay, can you just it's on the next one. This is a PPT folder. Just put it on the side. Okay, so let's start with our exact things, what we have come here to join. Now, like we have been to many industrial revolutions, okay? So there was a revolution where we have like a lot of industries coming together for completely hardware and mechanical things, okay? That was in the era of like 1960s or something. Later on, like we moved to a very IT based revolution, like where all the computers were there and all the whatever the hard work and the manual labor was shifting towards the IT part. Okay, so we had our Microsoft Office and all those things came into the picture, and whatever the analysis became from then and there. Okay, so now we have moved to a very unique kind of a revolution where we have a huge amount of data pouring to ourselves. Okay, so like we have the new kind of currency. The data is kind of a new currency in this particular era, particular revolution. Okay, so every year or every day there is huge amount of data has been poured. Okay, I'll manage this. Okay, so how much amount of data has been generated every day? It's around 2.5 quintillions of data has been generated per day. Now you can just amount or you can just realize 2.5 quintillion, like it's 25. After 25, you have to add 17 zeros, and that is the amount of data which has been generated every day. Okay, so the amount is very staggering. We don't know like what to do with this data. Okay, so 50% of the data is kind of a video images, audio images, or whatever the rest 50% is our infographic data. Okay, the message what you type on your WhatsApp, whatever the message you get on your mobiles, those all things come into the infographic messages, or whatever the financial documents companies been generating, banking financial records. So those are generated every day. Okay, and that sums up to 2.5 quintillion. Now we are expected that the amount of data in the worldwide right now, this particular thing was done in 2020. Okay, so that time we had around 44 zettabytes of data. 44 zettabytes, it's like 44 after that add 36 more zeros. So you can just imagine the huge amount of database we have currently, but we are not aware like how we can use or how we can present that data. Even just to imagine the quantity is difficult. How we can draw the inferences from there. Okay, so there comes our different EDA techniques and all. Whatever this data was generated, 44 zettabytes, 90% of this data was generated in the last 2 years, that is from 2018 and 2019. So it is kind of an exponential growth. Okay, we are expecting like whatever the analysis these people have done. So we are expecting that around 44 or 463 exabytes, like 463 quintillion bytes of data will be generated every day by the year 2025 or something. Okay, so it's still going on, and every day it will be going on. Right now we are in the age of social media, right? Everybody has their phone, WhatsApp, everything. What was the age you started your social media account? Around 18, 17, 16. Okay, it is expected by year 2030, a 6-year boy or 6-year guy will have a digital footprint. He will have his own social media account and all. So that kind of thing people are expecting. Okay, so when you go on your social media, you see like, okay, I'm just generating my profile. I'll meet good people. I'll have some career in that. So that kind of thing you are expecting. But what you are adding on your social media account? Your information, okay, from where you have then your college, from which field you are more interested to, in which field you are more inclined to, what are your likes, okay, what kind of social life you expect. So all these things is a data, and mainly the marketing companies are working on this data. They will analyze data for a lot of groups, and then they will present a certain marketing strategy like, okay, if you are into this kind of food and all, they will suggest a good restaurant to you. Okay, you know, like there are a lot of ads when you log into your Facebook account also. So where do they get this kind of idea? It's this kind of thing. Okay, so they analyze your data, explore whatever the hidden inferences, whatever, even you guys don't know like what you like, but they know how. That's analysis. Okay, so let's begin with our actual part. So this exploratory data analysis was basically come up like Mr. John Turkey was the guy who came up with this kind of statistical analysis thing. Okay, so what his actual scenario was, like he wanted to have, like whenever you have a data, now you are building a prediction model. Okay, so like if a particular what you have is a sales, okay, and you have advertisement. If you are doing like 95 advertisement a day on a certain TV industry, okay, that results to a certain amount of sale on your monthly basis. If your advertisement reduces, the sales also reduces. If your advertisement increases, the sales also increases. So such kind of prediction analysis are done. Okay, now what is suggested, like there are certain things to be accepted into the analytics, there are certain things which are to be rejected. So to have those ideas like what to be included, what to be rejected, we are doing the exploratory data analysis. Okay, so he came up with the certain strategies on that, and then we'll start with the EDA. Okay, so next. Okay, so what we have is, like whenever you are talking about this data, it is in tabular format. Most of the data is in tabular format for our concern. Okay, there are data like say for example you have a chat box. Okay, in that chat there is a feedback information, so you have to retrieve the information. So that comes into the machine learning or artificial intelligence part. Eventually, after those algorithms also, whatever the data you will get, it is in tabular format. But now, say for example, I have sales and what do you say, advertisement, 2 columns. That's fine. Okay, I can work with them. What if I say sales, company, time frame, around blah blah blah, up 10, I can go up to like thousands of columns. You cannot visualize that huge amount just a column wise. Okay, the variables. Later on, there is again a part like how many samples I have. Okay, say in normal days data, like we have worked with like 20-25 samples. Okay, in our exam paper, like in our, if we are analyzing something about our exam results also, teachers may have like, we have like 25 or 30 or 60 students, and they have their result. We can identify like, okay, the average result is this and that. Okay, we have from last year onwards, we have a certain growth in our percentage for the students and all. But when it comes to a huge data, say for example 25,000 rows, or I can say 10 lakh rows, I can have analysis of all the students who are affiliated to Osmania University, how much I can get, like 25 lakhs, somewhere around. So the amount of data is very staggering, and it's really, manually understanding the data is very difficult. You cannot understand like, okay, for 25 lakh people, how much is my average analysis, how much is my average growth every year. Okay, so for that kind of thing, we need to have EDA kind of tools which have been provided by different softwares. Okay, now what we do is in EDA we take the data in a tabular format, and with our softwares, with our algorithms, with our different tools, we manipulate that data to have, you know, the tabular form of data to a graphical thing. Okay, in graphical thing, what happens, like we have different kind of charts, plots, we convert them, and from that charts, plots, or even just a table, okay, a small instruction table, from that we can have other hidden inferences in our data set. Okay, so these are the main three basic conditions what we can do with the exploratory data analysis. Okay, so what are the objectives of exploratory data analysis is like what I already told. We have to find what exact parameters to be fed to have, you know, the prediction algorithm work properly. Okay, to have that we have to do the sorting of data, we have to remove some inferences from that data. So for that we use exploratory data analysis. Again, so for example, like predict this for the marketing strategy, people need some hidden inferences, like which kind of people to be targeted. Like, so for example, there are a group of people who will be targeted or who will be inclined to a European kind of a food. There will be people who will be inclined toward our Hyderabadi kind of a food, right? So those people should be targeted separately, and to have those inferences, we do this data analysis. Okay. So fine with the part, like understood the data analysis part. Now where this Python comes into the picture. Okay, there are a lot many softwares and tools, like Python is there, R is there, then there is SAS is there. We have like SQL also, little bit kind of analysis it can do, and plus we have n number of tools. Like every day, like Google is also going to come up with their tool. Google already has that. Yeah, there is Microsoft. You know, Microsoft Excel is there. It is also kind of a data analysis tool only. But in addition to that, there is a very specific thing we have to download in Microsoft Excel to have a little bit more advanced analytics. That is a pivoting table, right? So those kind of already things are there. But why we are going to Python? Python is kind of an open source. Like say example, if you are working in Python, you can come up with your own functions. Okay, if you feed a particular data set to that function, you will have whatever thing you have. So it is an open source. N number of people have contributed to such kind of functions and libraries and package, and including all these things, Python has come up with around 1,37,000 functions or libraries. Okay, so just you call that function and you can just run whatever you want. Okay, so it has become that easy for development, and it has that kind of vast tools. Okay, so this is for the Python part, and like we have like around different libraries, very important libraries in the Python. Okay, so pandas is one of the library which will help us to understand a data frame or whatever the data manipulation we have to do. Okay, making the data into that, whatever the tabular data we have, we are making that data to a specific, categorical variable or a numerical variable. We are adding something to the data. So that kind of operation has been provided by this pandas library. Okay. The next is our NumPy library, that is our numeric Python. Okay, so whatever the numerical calculations or manipulations have been done, like addition of numbers, addition of matrix, multiplication of matrix, so that becomes a very huge and different category. But those becomes very easy when we have this NumPy library. You have already learned about matrices, right? So how is it easy or difficult to calculate a conjugator for matrix? When we have like 3 by 3 matrix, it's easy. What about when I say I have like 1000 by 1000 matrix? It is hard, right? So such kind of library helps us in having that kind of functionality at our disposal with just one single line of code. Okay, so that's why Python is very easy to understand and very easy to implement. Then we have Matplotlib and Seaborn. So these are basically the graphical things what we have. Graphical function like pie charts, the scatter plots, line plots. So these kind of graphical tools have been provided by these two libraries. Matplotlib is little bit basic one. Seaborn is bit of advanced one, and you can have like whatever you can do on both the things also. Whatever you have like Matplotlib, you can do little bit extra on your Matplotlib. You can have a little bit of beautification of your graphs and plot, and you can have that. Okay. Then there is TensorFlows. Now, when we consider a matrix is a two-dimensional thing, a row and a column, right? When we go to the tensors, it's like three-dimensional part. So those kind of operations for a three-dimensional matrix can be done with the tensor. We have different kind of right now. I think so. You have only univariate data analysis where there is just one column. There is one dimensions. When you go to a bivariate analysis, it's just two columns. One row rows and columns. But when you go to a multivariate analysis, you have like number of rows, number of columns, and again there are certain more dimensions to that. So those things have been handled by TensorFlow. Along with TensorFlow, there is a PyTorch library is there. There is this PySpark library. Now, PySpark library is one of the best library what you can have when you are analyzing the big data. Okay. Now, what happens? You know, like how we are working on the computer. Computer, what it does, it takes a line from a code, it processes, then it moves to the next line, so on to the next line, and sequentially it will contribute or it will execute all the code. This is the basic thing, right? But now, as per our hardware part has been updated or upgraded, or we have multiple cores in our laptop. Okay, we have octa-core, we have hexa-core. My laptop is having around like 12 cores. So what this PySpark does is it also accesses one more very useful tool. Okay, that is Scala, or you can say Apache Spark. Okay, that is used to handle a big data. Big data in the sense like right now the file we'll be working with is like around 100 KB file is there. Okay, 100 KB or 200 KB file is there. But when we talk about a big data file, so it's around like 2 GB or 250 GB. That kind of huge files are there for our analysis. If you go on with the execution by line, just to analyze one single EDA, it will take a month, right? So what this particular PySpark or Apache Spark does is, it takes a particular function, it takes a particular program code, and whatever the processing is there, all the processing is divided into different number of cores into one laptop, or if I can access different computers, and I can put whatever my processing load on those computers also. So in that case, I'll have the parallel running of the codes, and whatever the 1 month time frame I'm going to take, that will happen in 10 or 15 minutes. So that kind of operation PySpark provide. Then there is OpenCV. OpenCV is just for image analysis. Okay, I can have an image, I can highlight a specific area of the image, I can build an algorithm to identify a particular face or a particular object. So that kind of thing is been done by OpenCV. Eventually, OpenCV also what it does is, it will take an image, it will convert that image to a numeric matrix. Okay, the image file, like it has pixels. Okay, the pixels are located in each row. There are n number of pixels and there are n number of columns. So we have an n by n matrix of pixels. Each pixel is divided into RGB color frame. Okay, so we have R, G, and B values, that is red, green, and blue proportion for that particular one pixel. And similarly, the OpenCV file converts our image data also to a numeric matrix, and then we can put that numeric matrix to our algorithm for analysis. So those things we can have. Okay. So now let's begin with our data analysis process. Okay, or exploratory data analysis. We are exploring the data and we are removing the hidden inferences or hidden information from those data. Okay. So what steps we have is, first step is loading the data. Okay, collecting the data from a CSV file, from an Excel file, from a JSON file, from an HTML file. There are n number of file formats, right? So from those file format, we have to load that data to our Python working environment. And once we load that, then we have different steps of cleaning the data. So whenever you get the data now, in the actual scenario, when you're working in a proper industry or when you're working in a proper company, so the data will never be clean data. Okay, you will have some missing values. So say for example, you are calculating a mean of income, okay, and in that income values, there are certain missing values. There are people who are not willing to, say what their salary is or what their income is. So when you are calculating the average income, that makes a problem, okay. The missing value, we cannot calculate the average because we are unknown about those things. So we have to remove or we have to filter out those income parts. When we have a certain data now, the format of the data is different. Say for example, Excel is there. In Excel, I can have there is a format of the table. Okay, there is a text format, there is a numeric format, there is a date time format. So whenever a CSV file is being read, it normally has a little bit of understanding like which is normal numeric data, which is categorical data. Okay, so it will take those data accordingly, but sometimes it may miscalculate. Say for example, a categorical data has been fed, but it will take it as a numeric data. So we have to convert that data. We have to make a clean data for analysis. I'll show you later on when we actually go towards the cleaning process. Okay. Then we have analysis part. So we have univariate analysis where a single variable is considered and we do the analysis on that single variable, like what is the distribution of that variable into our data set. Okay, how the values have been distributed, like how many counts of a certain huge values are there, what is the count of the lowest value. So those kind of univariate analysis we can do. We can plot histograms to visualize that. Okay, we can plot frequency table, like how much value, or if it is a categorical, if a categorical value A is there, how much values of A are there into a data set, how much values of B are there into data set. So that comes into univariate analysis. Okay, then we comes to a bivariate analysis. In bivariate analysis, we have two different variables where we can analyze the correlationship between these two variables. Like if one variable is increasing, what is the result on the second variable? So that comes into scatter plot. Okay, we can plot a scatter plot. We can see like, okay, if my X values are increasing, my Y values are also increasing. So there is a positive correlation. If my X values are increasing, my Y values are stable. So there is a very low correlation, or we can say a zero correlation. If we have like, if my X values are increasing and in my scatter plot, if I see the Y values decreasing, I can say I have a negative correlation. So such kind of correlations we can plot. Secondly, when we are talking about univariate analysis, we have also like one numeric variation, we take variable, and again we take a second variable as categorical. So we can define that one numeric variable, we can do a partition in that based upon a different categories, and we can analyze what is the average mean across those categories. Okay, so for example, students have different marks in different colleges, so I can analyze the marks with respect to just one complete thing, or I can just categorize into number of colleges. Within that category, I can also categorize it on number of subjects you have taken. So that kind of analysis I can do with this numeric data and continuous data. Continuous data and the categorical one. Again, there is one more very useful analysis, that is if we have two categorical variables. Okay, I can say like from the scatter plot, if I have continuous variable or numeric variable, it is easy to understand the correlation. But what if I have categorical variable? So for categorical variable, it becomes a little bit complex to understand the relationship or association of one category with the other. So that part also we'll study or we'll look on to the end. Okay. So let's begin with the actual analysis part. What we discussed earlier, this is a complete Python thing. Okay. The Python code and all I will be explaining. I'll just show you. Okay. So first thing, what we have discussed was the loading part. Okay. So for that, I will load important libraries. Okay. So this libraries is OS is for the operating system library. Whatever the operating system things will use, like accessing a specific directory or specific folder or saving to a specific folder. So that kind of thing I can do. Secondly, like for the pandas, the data frame and all, I'll use that. Matplot, Seaborn, and NumPy, as we already discussed, we'll be using those libraries. Okay. Then I'll be defining my environment according to whatever tools I have. Say for example, like I have this particular number of rows in my data set is around like 1,000 or 2,000 or 25,000. in this particular Python, whatever the window size we have, we cannot display all the variables at once, right? So I can find here the options like how many maximum rows I can display. Okay. Then there is how many maximum columns I can display. Also the maximum width of a column. Okay. Say for example, I have a name column. In name column, there is a the name of a person is there, which is very long. Or if there is an address column where we have an address of a particular person. So that comes up to like 300 or 4,000 or 400 characters. So I can have that limit also, like, okay, I want only the column names or column width up to like 8 characters or 10 characters or 50 characters. So that I can do. Now here, right now, the last I'm setting my working directories, okay? That os.chdir, that is basically for change directory function, okay? I'm just defining wherever I have saved my data file and all. So for loading data set now, whatever the data set what we have is into a CSV format, okay? Everybody is aware of the CSV format. CSV format is like, there is a complete row-wise or column-wise. Row-wise is already there, but how we define a column? In Excel, we have a number of limited columns. Okay, it starts from A, B, C, whatever it is there. Then after Z, it comes from A, B, like that. It goes up till ZZ. So we have like around 26 multiplied by 26 different columns are there. But here in CSV file, we don't have a fixed amount of columns. Okay, whenever a variable is defined, it is defined, then there is a comma, then there is the next variable. Okay, then there is again a comma, then there is the next variable, so on till how many n number of columns we want, we can have there. Okay, so that is a basic thing. When we talk about Excel, the number of columns, number of rows are already fixed. Okay, so based upon those fixed number of rows and fixed number of columns, the data size is also fixed somewhere approximate. Okay. Most of them are empty, so the empty are considered like a 0. But in CSV file, we do not have number of fixed columns or number of fixed rows. It is completely upon what we define. Okay, so that is main the CSV file. Now here, we are reading it into a data frame file. Okay, so that's why we have pd.dataframe. And from where we are reading? We are reading it from pd.read CSV file. So read CSV file is the function given by pandas data frame to read a CSV file. Okay, so what we have is our marketing data file. So I'll show you the data file also. So in the below, I have put a data frame. So we have already read our CSV file into a data frame named as df. So df is our calling function for our data frame. Okay, I'm just presenting 5 samples from the data frame and I'm using transpose functions. Okay, normally all the rows will be one by one, it will come. But what I have did is I have just transposed it so that I'll have number of columns in the row category and whatever the information into the column category. The screen is okay, so this is my data file what I have printed. You can see I have how many number of columns? I have around 28 columns. Okay, all columns are being represented as a row wise. Okay, the ID, year of birth, whatever the education status is there, the marital status, the income part, and all things. Okay, then there is a date, and so on. It goes on till the country part. Now, whatever my first column is there now, or the first row is there, this is just a random data points I have taken. Okay, ID part is there 149, oh sorry, 9,323, and so on, so on, so on. We do not do any analysis on the ID part. Okay, so we can just remove that when we go to the exam data cleaning part also. Okay, then there is year of birth. So in year of birth, we only get the year part. Can we have age from this year information? If you are doing it at this moment, this is 2022, right? So 2022 minus whatever the year parts I have for respective rows or respective samples. I can identify their age, and age wise I can categorize like, okay, age group from 10 to 20, how much wealth they have, income they have, from age group 20 to 30, how much income they have. So that kind of analysis I can draw. I can identify which age group is having most income. So this kind of inferences we have to draw, but for this you need to have the domain expertise also. Okay, so unless and until, okay, you have this data, you follow the steps, you follow the plots and everything, it's fine. But unless and until you have this domain expertise now, you don't know which plots to be taken into consideration. Because you see how many numbers of columns you have, 28. If you analyze 28 columns, okay, so we have histogram for 28 columns, you have histogram or the scatter plot for 28 into 28 columns. Okay, that kind of huge kind of analysis you will do. If you go on making the code for this analysis, it will be like around, say for example, 1,000 or 2,000 line of codes you will just do for this particular thing. If you just follow blindly what analysis you want. But if you have domain expertise now, you can understand, okay, ID is nothing, I can remove the ID part. Then, okay, education is fine. Age, from year of birth, I can identify the age. Whatever the monthly foods these people are purchasing, monthly meat, fish product, it is not needed in this kind of analysis. So I can just remove those things from the analysis part. So you have to have this identification of the domain expertise to identify which are your target variables on which you need to analyze. Okay. For this particular plot, for this particular data, we'll mainly concentrate on the income part for analysis. Now, can you see the income, how income has been described over here? There is a dollar sign, okay? Then there is a 49, then there is a comma. When you read, you have a human brain, you understand, okay, it's around $49,912 is the income of this particular plan. But when we feed that information to a computer, it will only understand it is a string variable. Okay. Then comes the picture of data frame. We have to remove that column, we have to remove the dollar sign, we have to remove the decimal point. Once you remove that, again you convert this string part to a numeric form and then you can do the analysis. Okay. That also will come. Next is date. Very important thing. Normally people miss this part, they just do the analysis on the whatever the remaining data is, but the date is a very important part. Okay, mainly for the time series data, not for this data, it will not be enough or it will not be sufficient. Say for example, we have a sales. Okay, what is the sales on this particular day, what is the sales on that particular day, so on. You have this. Okay, now in this data frame or in that particular data frame, you can club together what is the monthly sale. Okay, you can club that monthly sale to a monthly yearly sale also or quarterly sale also. So that kind of clubbing or grouping you can do. Again, if you have like for 2019 onwards, you have 2022 of data with respect to sales on every day. In each month of every year, what is the sales you can do with that kind of information with date. Okay. So the month wise I can go for, I can understand what is the trend of my business operations. Say for example, in month of January, in all 3 consecutive years, I'm getting a good sale. In month of March, I'm getting a very low sale. So for all this yearly basis, monthly basis, we can do. But for that, again, same thing, we have to convert this string information. It is normally been taken as string information to a date time information. So Panda already has one very important function, that is very important. What do you say? Category. Okay, we have numeric information or numeric variable where we have numbers. We have categorical variables where we have like characters or like say for example country also. There is one country is Middle East, so that is a category. Then other is Singapore, then other is US. So these comes into a category. So that kind of information we have, and then we have a date time also. Okay. So let's understand before we go for the cleaning part, we'll just understand our data sets. We already explained basic things. So here we have around, I'm printing shape of this data frame. Okay. So the shape of the data frame is printed at 2240 rows we have. Okay. And we have 28 columns or 28 variables. Okay, so let's first identify what are the number of missing variables. Okay, next. Okay, so here we have we are printing the information of the data frame. Okay, what are the information of the data frame? What we can see is ID. We have 2240 non-null characters. Okay, so on we go. What is the data type? Okay, the data type is numeric over here. That has been defined by integer 64 in 64. Okay, so on we can go. But you can see the income part. How many non-null characters I have? It's around 2216 non-null characters. So out of 2240 samples, there are around 26 or 25 something characters or something variables or values are missing from these things. Okay, so that we have to identify, and you can see here I have like different things also, like the object type or data type. We have object. Okay, so whenever we are like reading any string information, it has been taken as an object. So we have, by default, it is considered as categorical when we do the analysis. But when we do analysis for different things, like say for example recency or how many number of kids we have at home. Okay, here the data type is in 64 is the data type, so that is integer form. So if I have number of kids at my home like 0, 1 or 2, I can take it into a categorical variable. What is the income of people with 0 kids? It will be definitely more, right? Less distraction from your daily routine, more to your working schedule, and you have a bit more income. If you have more number of kids, your focus is differentiated or variated, and you have less income. So that kind of information we can have. Okay. So let's. I can also take to the next. Okay. So this is the first part. You have to remove the null characters. Okay. Now removing a null character is also very complicated thing. Say for example, you have ID information, IDs. Okay, ID column is there. There are null variables in those ID. What do? You'll remove those rows or you'll remove the column. It is up to you. It is up to your domain expertise. Okay, I know ID is not going to provide any information, useful information in my analysis. So I can drop the ID column itself. And once the null values are gone from the ID, whatever the remaining, I can analyze. Okay. Now, if I have some null columns or null values in our income part, as here you can see, I'm just printing the sum of all null values in each irrespective variables or each respective column. So for ID, I have 0. For year birth, I have 0. For income, I have 24. And for the rest, it's 0. So I cannot do analysis with the null variables. Okay, so what I'll do is I'll drop those null values. Okay, so to drop that, there is drop NA or drop null values is the function. Okay, df is equal to df dot drop NA. Okay, so that one I can drop. Similarly, I'm removing my ID also, so that whenever I'm analyzing, whenever I'm plotting, I don't need the ID thing to come. Okay, so I'm just dropping df dot drop ID. Axis I'm defining as 1. If I define the axis as 0, whatever the dropping function it will do, it will just drop row wise. It will find into a certain column if there is a ID variable, it will drop just that particular sample or that particular row. Okay, but now here I have to drop a particular column, so we are putting axis is equal to 1. Clear on that? Okay. So now this is also an important thing to analyze. You need to understand which is my categorical variable, which is my numerical variable. Okay. So what I'm doing is I'm printing the unique values in each row. Okay. The function is being provided by pandas data frame as usual. That is n unique, number of unique values. Okay. So for ID, how many number of unique values I have? 2216 values. For year of birth, how many values I have? 59. So on. Okay. Number of kid at home, how many values I have? 3. Basically, it is integer type. The values are 0, 1, and 2. Okay, but rather than taking it numeric values, there is no it doesn't make any sense. What is the average number of students in the home? Yeah, it makes a sense later on, but rather than having that kind of analysis is important, or having analysis like for income, for a number of kids, 0, how many income is there? For 1, how much income is there? For 2, how much income is? What makes more sense to you? So accordingly, that later on I will convert the number of kids at home to a categorical variable rather than taking it as a continuous one. Okay. Similarly, I go for teen of home, same thing I can do. Then I come to number of new purchases. I have 15 categories. I can use that 0, 1, 2, 3 up to 14. Rather than I can also take them as a continuous variable. I can plot whatever the scatter plot also. So it depends upon them. Can you explain me what is the difference between a continuous variable and a categorical numerical variable? There is a very small or very thin difference. If I have any continuous variable, okay, I can infinitely go and I can say it is a continuous. Okay, that is like from, say for example, 1 to 2. How many partition I can make in actual? I can make infinite partitions, right? 1.0000001, 1.00002, and so on. I can make infinite partitions. But when we talk about these partitions now, that one partition, can we consider it as a category? Yes, we can. That one partition, one single variable is there. What is the income for like 49,934 people is the income of certain people. How many people are having that kind of category who are having that income? So any continuous variable can also be converted to a categorical variable, and we can do the analysis of that. Okay, so this is a very thin line, and we have to understand whether a particular variable we have to take it as a continuous or a categorical one. Clear? So similarly, if I go to the accepted CMP, okay, what is the accepted terms and condition is there? So accepted terms and condition 1, it is either 0 or either 1. Whether I have accepted or I have not accepted. Can I have average of this? Like what is the average of this particular variable? It doesn't make any sense, right? So that needs to be converted to a categorical variable. Okay. So let's have a look how we do the category conversion. So a simple conversion thing is used. I'm defining that particular column. Now to access any column, now I can either use df a square bracket, and in the square bracket I can just put in double inverted quotes and whatever the column name is there. With that also I can access the column, or I can simply access the column with df dot column name. Okay, so these are just two techniques I can use to access the column. Now what I'm doing after accessing the column, I'm using as type function. Okay, this particular function helps me in converting a categorical variable to any other form, converting a numeric variable to any other form. So kind of a conversion thing, this particular as type function allows me. Okay, so let's see, what we are doing is we are converting a numeric variable to a category variable. So okay, category comma copy is equal to false. We are not replacing. Okay, we are not copying that particular column. We are converting or accessing or making a complete new column with category as a data type. Okay, so I've just done for the sum of the things, but mainly like, okay, whatever the recency is there, it's as per you whatever you are analyzing. Okay, so next comes date time format. Okay, so this particular thing, converting to a date time format is little bit different. Okay, so here I'm accessing pandas to date time function. Okay, and in that function I'm giving the column information. In that column information I'm passing an argument about the format. So whatever the date time I'm reading, it is in which complete format is it. I can say like it is %n. So %n means the starting two variables or two characters from that string is a month. Then there is a slash. Then next two columns is the day format, and then the slash, and then there is capital Y. Capital Y means next four characters are my year part. Sometimes what do? what is your birthday? Say for example, my birthday is 7 October 1989. What I can say 07/10/89. So here part I have defined in 2 characters. So in that case, I'll just put a small y. So there are different formats you can accept the date. Now this variable is date time format. So there is again further format differentiation that I can accept number of day. Sorry, yeah, hour of the day, hour, minutes, seconds, milliseconds. So those things are also there. Okay, sometimes it is a 24-hour format, sometimes it is a 12-hour format. So again, there is one more, whether it is the AM or PM. So this kind of format I can understand from here, and I can read those format accordingly. Okay, so let's come to the cleaning of this income part. So what I have? Dollar sign, comma sign, decimal sign. Okay, in cleaning income variable, I'm taking that variable as a string first. Once I read that string format, I'm replacing the dollar with a blank sign. Okay, so once I replace the dollar part with the null value, or replace the comma part with a blank, replace the decimal point with a blank, finally I get a variable like 49,912. It will not be like that also. It will be 49 lakhs or something, 4,99,000 and 1,200 something. Like that it will be there. Okay, when we remove this thing. So that's why what I did is I did divided by 10 or divided by 100. How many decimal points you have to remove? You have to remove 2 decimal points, so we will do 100 over here. Okay, so that kind of things, and then again I'm converting it to as type, and here rather than whatever the category you use, okay, for the categorical variable, here we have used integer 64. Okay, that is int 64. Now what does this int 64 means? Any idea? A little bit extra information is there. See, whenever I have any variable now, it is been numeric variable. Okay, say for example 2 is there. So whenever we are saving that 2 into a computer file, it is always converted to a binary code. Okay, so for 2, what is the binary code? 0000010. Okay, so how many binary information I use? 8 bytes. Okay, so that is integer 8. Okay, now there are certain big variables also. So if you are having like 8 byte of code, now how many maximum numbers I can store? Around somewhere around 1024. Okay, from 0 to 1024 integer values I can store in that particular 8-bit format. What if I have more than 1024? So then I have to go to 16-byte format, I have to go to 32-byte format, again I have to go to 64-byte format. So this in 64, whatever the number I have, that has been stored with 64-bit format. Okay, 64-bit format. Number of bits 64. Okay. So now after conversion, can you see the changes? Whatever the info we had printed earlier, there was integer all everywhere. Okay. Now we have a few more things. Date time 64 is there, and whatever the format it is using in nanoseconds. Okay. Whatever the date time I have, you know how we are representing a date in the computer. It is not always by month. It is just one single value is there that we call as a timestamp. So basically, what it calculates from a certain time frame. Say, for example, I think so it's on January 1st, 1956 something or 1958 something. From there onward, the timestamp started, and from there till that particular date, how many seconds, how many milliseconds, how many nanoseconds have been passed, that value has been stored into the date time object. Okay, it's not just number of month, number of date. It is not saved that way. Just one value, in fact, one numeric value. Then when we divide it accordingly, or when we differentiate, like okay, how many seconds are there that we do? You know the mod function. If say my timestamp is in here, it is in nanoseconds. If I say it's in seconds, okay. In in 1 minute, how many seconds are there? 60. So whatever the value I have, if I do a mod 60 on that, whatever the remainder I get, what is that? It is a second, extra seconds what have been passed. Okay, remaining part is number of minutes, right? Whatever the value I get after the mod function. Now, how many seconds, how many minutes are there in 1 hour? Whatever the the part I have, if I do mod 60 on that, I'll get number of extra minutes. Similarly, if I go with how many hours? 24, so I get the hour, the minute, the seconds. Similarly, whatever the remaining part is there, that is number of days. So that again, how many months, how many days are there in the month? 30, 31, 28, 29. So that way, first they calculate the year part from that. On year part, then they go like which month is there. If it is a leap year, then 28 for the February, or sorry, 29 for the February. If for the rest, it's 28. Then the month for January it is 31. For October it is 31. Then other it is 30 or something. So that kind of thing from a date time variable we can divide on. This is how the computer does it. Okay. Similarly, like, okay, that's fine. Rest of the things you hopefully understood, the integer, the categorical and all. Here. So next we move. Okay, one more thing. Here you can see the memory usage. How many, what is the memory? It's 431.4 KB, somewhere around. Okay. And how many data we have? We have around 22,240 data sets. Or in this case, when we filter out some things, we have 2,216 data sets. Now, there will be a, when we are actually working, we have 10 lakh, 20 lakh data sets. Okay, few days back, I was actually working on one of the data set which was just around 6 GB. So, understand this, the memory usage also part, like which you'll have. Now, if you have such a huge data, 6 GB or 7 GB, just removing one single column, now it will drop down your data to say like 500 MB can drop. So you have to remove or you have to clean the data accordingly, and you have, whenever you are analyzing, whenever data has been analyzed, its size has been considered a lot, right? So I'm just having univariate analysis. We are starting from here. Okay, there is one function describe. Okay, now whenever I'm describing the function now, I cannot print this much data into one's normal or output variable or output environment. So what I'm doing is I'm just saving that data to a CSV file. Okay, exporting out this data. Similarly, what you can do is whenever you are analyzing something, okay, you got your information, you are saving that information to a certain variable. You can export that variable to your computer. There is again, whenever you are plotting yours, you can save that plot to your computer. Okay. So this 2CSV does that. Okay, then there is a dot describe function. Now this is very important. You see here what functions I have or what variables I have here. Sorry, for my describe. ID is there, year birth is there, income is there, recency. Why there is no date? There is no date time. There is no accepted terms and condition variables. Those are categorical variables. Here, what we are describing is a basic thing for a numerical variable. Okay. Now, what we are doing is we are taking a mean, or firstly is we are taking the count. How many variables, how many samples we have for ID? 2,216. What is the mean of that particular thing? Okay, let's concentrate on income part of it. What is the mean of that income? It's around 52,247. Secondly, what is the standard deviation? How, this is very important thing, a standard deviation. When my data is there, now I have a mean information. Now from me, I say some of the people they have income of 1,000 also. Some people will have income of 90,000 also. My mean is coming around 50,000. Okay, just for your understanding. So how this spread is there? How much far my values are going? What is the frequency of those values in those things? So that is being calculated by standard deviation. Okay. Then we have mean and max. What is the lowest? It's 17,300 is the lowest income. What is the highest? Say somewhere around 6,66,660. So much 6, right? So this is the mean and max. What is this 25%, 50%, 75%? most of you will have an idea. This is the quartile information. Okay, I can say that 25% of my sample have income below 35,000, 3,53,000. Okay, 50% of my sample has average income of less than 5,13,000. Similarly, 75% of my sample has salary or income less than 6,80,000. So such kind of inferences you can have here with this also. Okay. Here based on this, can you categorize? Okay. Similarly, for recency, I can go for minimum wine purchase. Okay. This monthly wine purchase. Okay. We have some people are purchasing around 1,493 wines per month. So they are very rich people, right? I cannot with just looking at the graph. I'll show you better with the graph also later on. With just looking at tabular format or tabular value, I cannot draw these inferences. To have these inferences, you need to understand the graph. You need to plot a certain variables, cross manipulate it. Then you'll have that inference is very clear. Okay. So, univariate analysis, one of the basic part, plotting a graph. Okay, I'm just considering, first we'll go in with the categorical variable. So when you are doing univariate analysis steps for a categorical variable are different, for a numeric variable are different. What we saw earlier, describe function was kind of a for a numeric variable only. But now when we go to categorical variable, there are two main things. First is a histogram. Okay, I have histogram for the country. Okay, in country, what was there? There was SA, SP, CA, and all. So that kind of things were there. I can say here, most of the sample I have collected. Okay, 50% of those samples are from Singapore, right? Around 1% are from rest other parts, 1 or 10%, and there are very small amount of samples. Those are from Middle East. Say if this is from a company database, na? I can say like my employees are spread accordingly like this. Whatever my CEO is there, he's sitting in the Middle East, and from there he's maintaining all the operations. Main of the operation site is Singapore. It's kind of head office. So this kind of information I can take from a histogram of a categorical data. Okay. Again, a pie chart. Whatever the histogram information I have, I can convert it into a percentile thing, and in percentile thing, I can plot a pie chart. Same thing, everything is been same. Okay, if you see the command also for a histogram, what is the command? Choosing a data frame. From that data frame, I'm choosing a column country. From that country, I'm doing a value count on that. Okay, and the value count is normalized. So whatever my values are there, so those values is been normalized from 0 to 100. That becomes a percentage information. Okay, and I'm just putting a plot which is bar horizontal plot. So up till here, the command is clear. Now, if you look at the pie chart also, data frame, country, value count, normalized through plot up till here is same. I'm just rather than bar horizontal, I'm putting pie. Okay, so now it gives me a pie chart. So such kind of information is very important, right? When you see a different information like sales, what is the sales from respective category of items? Say each company has a number of products. What is the sales from each and respective product? So that you can have this way. Okay, there I have put like country dot value count. What does value count actually gives us? There are around 1,093 samples from Singapore. There are around 337 samples from South Africa, 266 from Canada, so on. From Middle East, I have 3 samples. Right? Clear up to this point? So what is value count gives, and how we can this particular value count only is converted to a pie chart or a histogram plot. Okay. Next is univariate analysis for our continuous variable. Okay, so first thing what I've done is I'm again formatting my environment to f. The percent dot to f is basically a function what I'm using to have whatever the values up to 2 decimal points only. Okay, so that's the function. Sometimes what happens is then if the number is too big, like 66666, it's too big, right? Then what it will do is it will create like 6.6 into e raised to something like that. It will do. To avoid that, I just format it so that my display will be in this format. Okay. So now what we did is earlier you had described function on all the data frame, but here we can do it for individual also. Okay. So this individual thing is there. Now histogram for income. Now here this is very important to understand, and this is the basic concept. Okay. So what happens is plot dot histogram, very simple, straightforward thing. And then there is a density plot. Now histogram, you know, whatever the count is there for the income part, that is there, and density plot is just whatever the count is there, that is converted to probability values or the density values, and then we have overlap of density and histogram. This does not look appealing. You cannot understand, right? What information we have. It's very, blur information is there. Box plot also one kind of univariate analysis for this. Whatever it's really, I cannot predict anything from here. I cannot have any inferences. One thing I can have, okay? When you see about this box plot, these dots, what are those dots? Those are the outliers, okay? There is one outlier is like it's around 6666. Mainly, whatever my income data is there, basically what this box plot does is, whatever my income data is, it's only limited to like 1,40,000. Maximum income is only up till there for maximum population. There are very few outstanding personnel who have that kind of income, 66 lakhs. Yeah, like kind of a Sundar Pichai kind of a people. Okay, should we consider them into analyzing our general population? No. So whatever our analysis is there, we have to remove this kind of exceptional or something out of the box people to have a general understanding of our general population. Okay. So in next step, what I do is I'm making a new data frame, okay, BF1, and in that BF1, I have the information of people who are having salary less than 14 lakhs only. So this limits my population to my general population. I have removed the outlier information. Okay. After removing the outlier information, I am putting the shape again. Somewhere around 8 variables or 8 samples have been removed. Okay. My last count was 2,216. Now next sample count is 2,208. So 8 samples have been removed or dropped from the data frame. Now, as I remove this, you can see there has been change in the mean also. Just removing 8 people, you see there is how much difference? There is around 1 lakh difference in the mean. Okay, so this mainly affects our mean part. Okay, mean, average, median part, mainly affect. Now, after this, I put the same plots. Okay, data frame dot income, histogram, distribution plot. Now you can identify some hidden inferences. What is the average amount of salary people are having? I can say people are having around like from 2 lakhs to 8 lakhs. This is the average salary. Some go up to 14 lakh. Here, this is e raised to 6. Okay, so whatever the information is there, 0.4 multiplied by 10 raised to 6. That happens. Okay. So same, whatever my data is there, that is mainly, or my samples or mainly my general population has an average salary which falls into the range of 4 lakhs to 8 lakhs. Okay, so this I can have inferences from my plot. Okay, so such kind of plots we have to do, and from the such plots we have to remove the such kind of inferences. Okay, now if I put the box plot also, box plot mainly gives me the information same. What is my lowest salary? Whatever the describe function was giving, huh? The lowest, the maximum, the median, the 25%, the 50%, the 75%. So this is basically 25% category. Okay, this is 50%. This is 75%. Okay. So this is why the box plot is this. So you have to do the box plot for all the variables. Depending upon this box plot, you have to keep on cleaning or keep on filtering your data frame until you reach a final data frame which will be more suitable for your prediction model. Okay, guys. So other than box plot, there is Boolean plot also. Very confusing. Is it confusing? But you have already studied this. This particular Boolean plot, it's kind of a group function. It has information about the box plot. It has information about the histogram. So both the plots are merged together, and we have our Boolean plot. Okay. So somewhere around this point, this line, end of this line, this gives us the minimum value. This gives us the maximum value. This is our median. This is our 25% quartile. This is 75% quartile. When you see the plot over here, this is the same as our distribution plot. You see, the curve is similar. So this is kind of a group plot. So you can have such kind of plot to make your presentation more beautiful. Okay. There are still more plots are there. Okay. Now next we move to a bivariate analysis. Now why this bivariate analysis is used? We can use this to understand the relationship between two variables. Now, what are the variables? Now, same thing I have done. I have created an age column. Okay, how I have created 2021 minus the whatever the data frame value I have for my year of birth, and then I have plotted income versus age. Now, as my age increases, there are again certain very exceptional people who survived up till 120 years also. Okay, so no need to have consider them. We can remove that. This is my target part. Okay, whatever analysis I'll do on this part. Okay, now if you see, it is completely a spread up thing. Okay, if I have a correlation coefficient of this, okay, you can see there is a NP, NumPy library I'm using. NumPy dot correlation of coefficient for age and income. It is basically coming up till 0.21 I'm consider. Okay, it's kind of a matrix it gives me. Okay, one is like the correlation coefficient of age with respect to age only, and and income with respect to income only. So that one is there. Then again, there is another two coefficient. One is with age with respect to income, and one the lower part is income with respect to age. Basically, it is the same, vice versa. Okay, so that's why we are getting a symmetric matrix. Okay, now here the main key point is the 0.21. So for the correlation of coefficient is when it is near to the 0, it's always between 1 to -1. Okay, when it is near to 0, it is like there is no correlation, there is less correlation. Okay, when it is nearer to 1, there is a maximum correlation, maximum positive correlation. That is when my x value, when my age increases, my income will also increase. Okay, and then there is a negative correlation. Okay, that is when the correlation coefficient goes to -1. It comes near to the -1. There is no actual 0. There is no practical 1. There is no practical -1. It is somewhere between the range. Okay. Now, when I have negative correlation, when my age increases, my income will decrease. Okay. So, say for example, if I have that kind of information, if I can easily assume that the people who have born into current decades have good opportunity for higher income values, higher income jobs. That's kind of an inference, right? But we don't have that kind of correlation, so we can proceed to the next. Okay, I tried to do this. Okay, the monthly wine purchased by individual based upon their income. Can you identify the correlation here? How much is my correlation value? 0.57. Okay, and as for the graph also you can see For people who are having 0 ones, their monthly income is also less. As my income increases, number of points are purchase are also increasing. So easily you can draw the references. Rich people are having more wine, more parties, more celebrations, right? So such kind of inferences you can draw from here. Okay, so understand about the scatter plot. Now, along with the scatter plot, there is one more very important thing. There is line plot is also there. It is for also bivariate when we have X value and Y value. But that is mainly used when we have a sequential information. Okay, like say for a time series data, January what is the sale, February what is the sale. We can draw a sequential line, but right now we don't have that kind of data, so we have skipped. But eventually it will be the same. df1 dot plot line plot. I'll give X values, I'll give Y values. It's that easy. Later on, what you can do is you can have your beautification thing. The plots, the dots, whatever you want. It should be a single dot. It should be a empty slot. It should be a star. So that kind of point information you can do. Okay. Whatever the color here, by default it's blue. If you want red color, if you want purple color, you can have that color change also. Whatever the titles of this labels are there. Okay. Using X limit function, X lim. Okay, you can target the labels from the lower things. X text function is there, then Y text function is there. So we can beautify these things with those kind of functions. Okay. Then there is pair plot is there. So it's kind of a very beautiful thing to have. Okay. This has been provided by Seaborn library. You see this matplotlib, very basic plot they are giving us. Right? Now you see the beauty of this Seaborn. This is pair plot. I have plot of age with respect to income, just lower bottom. Okay. You see it's kind of a rough. Okay. Then I have income with respect to monthly one, income with respect to monthly gold products purchased, income with respect to income. When we have a plot with respect to one cell, it is a histogram plot. So all the diagonal plots are the histogram. All this income or non-diagonal plots, those are the scatter plots. Now you see there is a difference. Income with age is different, and again there is the age part. Age with here. This income with respect to age, that is also different. Okay, so little bit of variance is there to understand like how correlation happens. Okay. With this one single plot, you can identify. Okay, I mean, I can say my monthly one is highly correlated to the income part. Then again, monthly gold products are also highly correlated to the income part. Okay, when I'm talking about the monthly gold products, I don't see monthly gold products and monthly wine very much correlated. Okay, similarly, I can go for the monthly wine part also. I don't see much correlation except for the income part. So I can identify which variables I can take to do my prediction. Okay. So next is the heat map. Okay, the code for the heat map is here. SNS. It's also again provided by Seaborn library. Okay. What it gives me? It gives me the correlation coefficient for each and every possible combination of my data frame columns. Okay. So I have a heat map of the correlation coefficient with age versus income, age with respect to monthly wine, age with respect to monthly gold products, and so on. Okay. So here, can you understand this? From this, I can design my prediction model. I can see my income is mainly correlated with the monthly wine purchase. Very little bit less with monthly gold products, and there is no correlation between age and income. Okay, so this is the heat map. I have different colors for like if it is going up till 1, I have a very dark red color. If it is going up till 0, okay, it's like somewhere around white color. Again, if I have like negative correlation coefficient, it will have a different kind of color also. Okay, so for example, red on the top, white in the middle, and blue at the bottom. So that kind of heat map also I can have. Now, bivariate analysis with one continuous variable and one categorical variable, what we have already discussed. Okay. See what is the beauty. My group function is kid home. How many kids I have at home? I have divided or categorized my income column into these two different categories. Okay. What is my income when I have 0 kids? You see there is a box plot over here. Okay. Average is somewhere the mean part, whatever it's there, it's coming around 6 lakhs. 6 lakhs is my average income with no kids. Then if I am having 1 kid, my average is average is 3 lakhs. Similarly, if I am having 2 kids, my average is 3 lakhs. But you see, 3 lakhs 81,000 and 3 lakhs 91,000 doesn't make any difference. So, what is my differentiation condition? If I have any number of kids, my focus is divided. I cannot concentrate more on my work. If I have no kids, good focus on the work, good salary, good growth, right? So this kind of inferences, qualitative inferences you can withdraw. Okay. Then same thing, distribution of with respect to whatever that distribution plot we have drawn, right? Histogram. So that histogram distribution plot can also be drawn with the grouping function from the category. Okay. SNS I'm using Seaborn distribution plot. I'm giving my data as my data frame 1. Okay. What is the hue? That is my bifurcating variable. Okay. Or categorizing variable. So categorizing variable is kid home. Okay. On which category I want to plot this plot? That is my x value is income. Okay. And KD is a distribution plot. Okay. Can it is something distribution is there. There is histogram also kind of you can draw. I'm just filling it. Okay. A particular plot, whatever you see, there is a little bit shade of orange, little bit shade of blue. So that has been done by fill. Okay. Legends I'm putting as to what are legends? This kid home. The blue is for 0. The red part or the yellow part is for 1 kid. The green part is for 2 kids. Okay. Height, whatever the height is there for this particular plots, and the aspect ratio is 1.6. These are just bandwidth is adjusted to 1. Okay, so these are the information. These are the things what you can draw. Then there is this last part, bivariate analysis between 2 categorical variables. Now, when we talk about these 2 categorical variables, now having correlation is difficult. You see I'm just taking a cross tabulation. Okay. Now for cross tabulation, I'm putting one variable as response from, like, if you are getting a response to a particular advertisement, yes or no. Okay. So it is 0 or 1 from the people. Okay. From Australia, I'm getting no response, 125 with no response, and 22 with response. Similarly, I go on to Canada. I have 227 people with no response and 38 people with response. If I'm going to Germany, 99 with response, 17 no response. So such kind of cross tabulation I have. Now, if you have row-wise addition, okay, 125 plus 227 plus 99 plus 133, it gives me total number of response, no response from all the sample. Okay, and then again, if I do for addition for response of 1, okay, that is 22 plus 38, I'll have value for responses for all the samples. So this is kind of a cross tabulation. Now what we do is, there is one more step, but that is too complex for you to understand. There is one test we run on this kind of cross tabulation, that is chi-square test. Okay, this test gives us the hypothesis whether to accept that there is a correlation or the association with these two, or there is no correlation, or there is no association. So clear on this? But basically, just if you have this kind of chart also within your table, now it is more efficient. So these are our stats for a particular response from different countries, right? And then one of the best is this one. One continuous variable and two categorical variables. Okay. Again, this is being provided by Seaborn library. Okay, there is a box plot only. What is my country? Is my X variable or one categorical variable. Okay. Then my Y variable is continuous variable, which is my income. Now, again, within this particular box plot, I again want the categorical differentiation. So that I'm giving at the hill. Okay. The hill I'm giving number of kids home. So here I have this one slot that is for Singapore. What is my income for 0 kids, for 1 kids, for 2 kids. Similarly, if I go for Canada, all those things same. Okay, so that's it from my side. I hope we have covered most of the things. Conclusion, like whatever the inferences we have drawn, how we can use this kind of information. Now, when we reach to the final part here, we'll have done the box plot for n number of things. Okay, n number of variables. From each number, when we are doing, we are removing the, what do you say, the outliers. We keep on removing the outliers from the specific things, and so on, so on. And finally, we reach to a certain filtered out data frame. Okay, that filtered out data frame with a specific columns available for the correlation. What I can do is, whatever the columns which are not correlated with the income part, I can drop them, and I can reach to a final conclusion like, okay, this is my useful data frame. I can put this data frame to my linear regression model or logistic regression model or any prediction model, okay, or any classification model or any machine learning algorithm, and I can have a certain useful prediction, useful objectives concluded to that part. Okay, clear with this? Okay. That's it from my side. Any questions? Whatever we have discussed is a very huge part. We normally take like around 3 to 4 lectures of each 2 hours to conclude all these things. So you should have some questions. Any, ma'am, can you check if there are any questions from the online portal? Come on, guys, you should have some questions. Having domain expertise.
We'll ask questions. We're asking to show you the Python, how it will be.
The thing is that I think it's in my laptop. If we do not have HDMI cables, so I can plug it. No, the thing is, this is the HDMI cable is faulty. That's why I have transferred my internet is also not correct. Online platform for the Python is not there. The thing is that the codes are only there. Codes and there. Yes. Tomorrow please do it because of all there I have to do it.
Girl, silence.
I do have the code already there. I'm using Spider. Spider. Yeah. PCT script. It's already there.
Some part of data.
maybe it's not a confidential.
No, that's not a confidential. What I have shared is I have my PPT, I have my script part I will show, and my data set is also I have shared. So all that. Guys, at least talking to yourself, I hope you can give us a little bit of feedback. How was the session? Whether you have understood anything else, you need extra information on. You are the domain experts now.
So we invite students to present representation from other colleges. Yes, the colleges who are representing your respective colleges, how many ever you are, one of you can come down and let us know if you want more, or was it too less, or was it too more, was it above your head? Let's enter. So we would also like to take a feedback. Why wait till tomorrow? We have enough time. So because of starting late, sir tried to finish it by 12 because we are having another session at 12:30 for another set of students. So can I invite representatives from colleges, Koti Women's, GDC Begum Pate, Reddy College also is here? Yeah.
Nothing much. You can stand in your respective places and let us know what was that you had come all the way to here. Was it already what you know, or definitely helps us to improve, add, because we have one more session tomorrow. We can plan, and sir is eagerly waiting to hear how much you have received. You've been talking, I've been observing, that's the reason why I've been walking down the aisle, up and down. I've seen none of you were writing any notes, so I thought maybe you are experts in the subject. So, yeah, the last show, I had a chat with you, right? From Koti Women's. Can I hear from you? Any one of you? You had, yeah, please. Thanks for standing. Could you come down here or talk from there? Let us know what was that you already learned or you had more to add.
There's no need to shy away. The more you speak, it will be more better for you to understand.
Yes. And we also would like to know what else you want to know.
I hope we'll be doing a lot more sessions like this, and we'll keep on improving.
Yes, St.Ann's College. Do you want to cut the monotony here? You want to break it? Asking you, so instead you started to ask now.
It's fine, it's fine, it's fine.
Go ahead. Go ahead.
About the libraries, sir. We can use different libraries for different.
Yes.
So the data will be stored in those different libraries and then.
No. The question is, when we have these different libraries, whether the data what we have, it will be stored into a different libraries or what?
Yes.
Basically, what is the library? It's like, for example, say I have some function. Okay, what does it do? X plus y. It will give me a certain value.
Yes.
Okay. Now here, what I'll do is I'll pass the value of x, say for example 10. I'll pass my value of y. It's example 15. So what is the value of z? 25. Now the values will never be stored into any library. What that library will do, it will just follow whatever the arguments it has received, 10 and 20, 15. On basis of those arguments, it will just do the addition and it will return the 25 value. So this is the function of a library. Okay. What will the Seaborn library displot do? It will accept the values of x column, y column. It will make a plot and it will return you the plot. It will not store any value into a library. Okay. So for all libraries, all functions, it's one and the same thing. Okay. Ma'am, tomorrow I will definitely show. We have a little bit rush of time.
Because the theory, I think,
Before holidays, I was already using the FCL app. And connecting the project with the function. No, it was working fine, but today only I think so. We will have it. If we want, we can extend a little bit half an hour. This part of our cover. Ma'am, can you go through the pattern? No, this happens. You know you are teaching already, so anything you want extra.
Basically, which we start is the same thing we are going to call. But they were more practical, but more probably they will use the R.
Yeah, it's not.
R
Similar
to the R.
very similar. R and Python, it's like brothers and sisters. Okay, just sometimes you call them with a different name. Functions will be somewhat similar. We'll have something to watch. But I hope whatever we have taught this particular session, I added a little bit of animation. Yeah. Definitely. What I can do is later on, if you want, I can share you the script, different for data manipulation, what the functions we have, for graphical representation, what functions we have. Okay.
Good morning, respected faculty and students. I am from GDC W Begumpet. As this class today about the Python and coding was very helpful to us because in our college we are the first batch for business analytics and the in-depth subject has been explained here. This will be helpful for the future career path, and even our faculty ma'am, Bhargavi ma'am, used to teach us everything about in detail about the topics has taught here, and even this would be helpful for our next batch students also. And thank you for giving me this opportunity to talk here, and this is a great platform for us to learn new things. Thank you.
She took all the courage to come and talk. We've invited around 150 students are seated here. So she really requires a very good applause for coming down and talking her mind. In fact, for the past half an hour I've been observing, you've been having internal chats. You can always talk with your neighbor anytime. She's there with you for the next part of the day and probably she's your classmate. Girls, this was a great opportunity to host this kind of a workshop. Of course, we had some technical glitches, but the expert resource person here with us today is no normal person. He has got a vast exposure, knowledge. He's been working on he's worked in places like Dubai, and he's been a resource person in IOA for quite some time. And due credits to him, he's been quite acknowledged in his field of knowledge. So we have invited him. He's taken time to be here with us from Bangalore, and the response from you should be more positive. Anyway, it was a delay. We started late, though we thought 9:30. We took it to 10:15, I guess, by the time we started. In the meanwhile, many had joined us. We didn't expect such a big turnout. We kept the Google form open till it's still open, people are still joining. In fact, we wanted to close it late night, but there were requests from few faculty. And this particular flyer had been posted in all the Telangana college IQAC coordinators. So we started receiving several calls even from IIITH Hyderabad. The faculty had called us to say that there are two faculties who have joined. Looks like they're online. I do not know their names. So this was exclusively for a student workshop, but even faculties have joined. Look at their interest. Students, when we give everything to you in a platter, probably the response is low. But you need to understand the efforts. The subject is totally new. I absolutely agree with the student who spoke from GDC. So this BCom analytics, business analytics has been introduced just 2 years ago. So there's the first batch which is in the final year. So I'm sure even the faculties found it difficult with the syllabus, too vast a syllabus. A lot of statistics have to be taught to them before they get into the subject. A lot of computer applications. And you can imagine the plight of a faculty who is a core statistician who have to bring it to concepts of a little bit of business, understanding the business background, applications, and they're finding it a huge task. The subject is just evolving, right? It's going to evolve, and analytics is the future. That's why we are given the theme, business and data analytics, the future of everything. So we understood in the next coming few years, you will see analytics in every field. Probably you will not know analytics is working in everything that you are operating, in everything for that matter. But analytics is there, it has become part of our life. So probably we are not acknowledging it. Okay, anyway, we are at the end of the session day 1 today. Hope to see you tomorrow again. So I indeed take a pleasure in proposing the vote of thanks. I'm Mrs. Anuradha, Head Department of Commerce at Department of St.Ann's College for Women. And I thank all the participants for actively coming down to the college campus. And I hope you utilize this opportunity. Sir is available with us today and tomorrow. He's promised us to show the Python platform. And tomorrow we'll be doing Power BI. And a lot of preparation had happened to take this workshop to this level. We have to coordinate. This has been happening for a month now. And I deem it my most important duty to thank Dr. Vinod Murthy, who has been instrumental in volunteering to help us out to conduct a workshop. And Professor Imran, who is amidst us, has taken the pains to ensure that he is available despite his busy schedule. He has to catch a flight tomorrow. He's leaving tomorrow, but he's made it possible because we've been repeatedly requesting him to conduct this workshop. So I immensely thank you, sir. And very embarrassed, but then it was beyond our scope of enabling it quickly. But thankfully, it had started by 10:15. And I also thank Dr. Sai Sharada. We've been discussing with the subject on what should be offered to you. So we assume that EDA with Python, we had a series of webinar 2 years back when the students were in the first year. So we thought we'll take it to another level with Python, the free resource. Is that what I understand? It is easily accessible. I'm no technical person. My core is costing, accounts, taxation, financial reporting, others. I do not know much of analytics. But definitely it interests us when sir was talking about multivariate, bivariate. We use all this in our research and the hypothesis testing. So it did interest me, but because of too many obligations I've been running about, otherwise I would have sat through and made my notes. Yes, I would have done that. We are all sincere students when we go to seminars and conferences. I'm sure we all sit through that 6 hours, 7 hours. You know, we go to conferences which starts at around 8 o'clock, 9 o'clock sometimes, goes on until 5:36. I'm sure faculty here agrees. We sit through all these seminars and conferences, and St. Ann is a place where we have we are totally, almost every month, we have 1 or 2 conferences, workshops, seminars, faculty do attend. We are there from morning to evening, making notes, giving reports, attending, writing some assignments, and we too have to give our presentations. So we are not free on the subject, and again we have to attend to all this. So I thank Dr. Sai Sharada, the program coordinator, Mrs. Supriya, and all my faculty members. Of course, my principal, Dr. Sister Priyamrita, academics dean. She's always been forthcoming in enabling us with whatever we require. And you can see a place of this kind, it's a huge venue where we can have all the technical support. So this is constantly booked and the venue is busy. So it got delayed and today we are 17th and 18th, we could book. But for tomorrow, this venue is again used for nutrition department. So you will not be seated here, you will be in the ground floor. There's a similar venue in the ground floor, it's room number 47. So for the participants who are joining us tomorrow, please come straight to room number 47. So shall we start by 9 tomorrow, 9:30? 9? We'll start by 9. Okay, so in case we have the feasibility, it has got net connection. It is, it's all, yes, all that is enabled in the ground floor. It's a similar hall, but it is not AC with all the other facilities, but it has got all the ICT connections. So you'll be seated in that hall tomorrow, and whatever you wish to see, the practical part of Python, maybe you will be able to have a view tomorrow, and MS Power BI is what we are going to do. Girls, it's a humble request. Please be active participants for all the trouble you took here to come and make notes. It will be of use to you. And I'm sure your certification also will hold good. And if you participate in that competition that we propose, the poster competition, every bit of the certification, your conferences, any credentials that you carry, you will get to understand how important they are when you go through placements. They ask you so many things, then you will realize, I missed that chance, I missed this chance. When it is being offered to you, you don't realize its importance. We calculate all these and then only we offer all such kind of workshops or seminars. So please be vigilant. All this will add to your credentials and it will be helpful to you at the time of placements. So I thank all of you once again and hoping to see you tomorrow morning. And the participants on the blended mode on the online mode, we close for today with the national anthem and we join back again tomorrow at 9 o'clock. Before you leave, you please collect your snack and you can leave the campus. Thank you.
Yes, girls, quiet. Please stand for the national anthem.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद।
Girls, please be seated. The snack will be served in the hall itself. You can take as you leave. We're just waiting for them to be brought in. Just wait for a few minutes before you leave. A Google form for the feedback, which will attach the certificate of participation. Yes, girls. Can I have your attention? An important announcement. So tomorrow a feedback link will be posted in the group. and you will get your certificate once you give the feedback. Coming to the participation in the competition for tomorrow, we request you to send in your e-copy to the Commerce NL, that was our newsletter, at gmail.com. So please post in your entries. And once we are done with the seminar tomorrow morning, that is the workshop, half an hour, there will be judging by Dr. Imran and Dr. Sai Sharada, who will be your judges for the poster competition. So we expect you to submit a color print copy of A3 size before the competition begins. And you will have to explain what you have done. Depends on the time, whether we start at 11:30 or 12. So an e-copy and a hard copy has to be submitted. And any specific queries after we close, you're welcome to inquire. Thank you.